Hello guys, let's start with an interesting question. Hey, look at the question guys. Find the angle between the line joining the lines here, note the point. Find the angle between the lines joining the origin to the point of intersection of the curve x square plus 2xy plus y square plus 2x plus 2y minus 5 is equals to 0. And the line is 3x minus y plus 1 is equals to 0. Like, let's understand the question first. To understand the question, let's represent it graphically. I'm taking variables instead of numbers because when we change the problem, variables will be much more convenient rather than the whole problem. Okay, taking ax square plus instead of 2hy the general format I'm taking just h. See, vy square gx fy plus c equals to 0. Add sliders to all these things. Okay, nice question, right? Okay. Now let's add the change the values according to the question. First one, a value be, let's take the a value be 2 and h value also 2, b 2, b value 1, g value be 2, 2, c minus 1. See, look, the equation represents an ellipse. See, an elliptical circle which looks like this. And there is also a line given in the equation which is 3x minus y plus 1. I'm also generalizing it. Ax plus y plus c equals to, sorry, let's use some new variables. Lx plus lx plus my plus k equals to 0. Okay, this is the line. So let's get the values. 1, 3 minus 1 and plus 1. 3 minus 1 and plus 1. 3 minus 1 and plus 1. You see, this we have to find the, look at this line 3x minus y, the green line intersects the ellipse at 2 points, right? We have to draw two lines from origin to the first intersection and from the origin to the second intersection, and we have to find the angle between the lines which join the intersection of this line to the curve. That is the question. Okay, the line is clear and ellipse is clear. So now we have to find the the equation for the pair of straight lines which joins these 2 points. Okay, seems tricky, right? Let's see how we solve this thing. Okay, which means, like, imagine this is the solution. To solve this question, we have to keep one thing in mind. Ax square plus 2hxy plus by square, this is the equation, right? The curve, the curve equation must be equal to the line equation, because we do not want to change the intersection point, which means the new pair of straight lines must and should pass through these two intersection points and an origin. You get this, right? We have, there are two lines in here. One line touches through the one intersection and the origin, the other line touches to the other intersection and the origin. See, mm, let's play with this. I have an idea about how we do it. See, there is a line, this line lx plus my plus k is equals to 0. And let's, how do we write it in slope intercept form? Let's see, let's write it in slope intercept form. Lx plus my plus k is equals to 1. Let's write it in intercept form, because in intercept form there will be is one on the other side, and the rest of the things will be on the left side. Or we can also write it as lx plus my plus k plus 1 is equals to 1. Instead of converting it into a slope intercept form or an intercept form where we get the right hand value will be 1, we can also add 1 to this equation, because as we can see in here the value of it is 0, and we can add 1 to this side. So let's see, the answer will be 1. Hmm? The solution here, I'm copying it. Let's see, let me zoom it a bit into the equation. Okay, opening the bracket, paste, and plus 1, close it. Okay, here when you observe this line, you can see that we are multiplying this value g of x with this value, and what is the solution? The answer is 1, which means the solution for this graph isn't gonna change. The solution isn't gonna change, which means the intersection points are gonna be fixed. And go to, let's do the same thing with y. Control C, whole square. um, you might have a doubt. We are multiplying these only these first degree terms with the equation. Why not multiply these terms ax square plus 2hxy plus by square with the other terms? Because there is a wonderful reason for this equation. Here we want two lines, which means it is a form of a pair of straight line. What is the degree for a pair of straight line? The power should not exceed 2. If you multiply ax square with lx plus my plus k plus 1, the answer will be some alx cube. You will get in the answer there will be ax l cube. A cubic equation is not a form of a pair of straight line, so we do not multiply this with the other terms, with the lx plus with the line. Get it? Same goes here. Here h value has to be here, hy there. When we multiply it, h into x square y, there won't be any x square y format in a pair of straight line format. As we know, the general form of a pair of straight line, ax square plus 2hxy plus by square plus gx plus 2gx plus 2fy plus c is equals to 0. We have to satisfy it. That's the reason we do not multiply the 1 on this side. Okay, with by multiplying with only 1, the answer remains constant. Keep that in mind. That's the only. And we have the both of these pair of straight lines passes through the origin. Look, both of these pair of straight lines passes through the origin, and we multiplied the c with the whole square. You can also leave it as you might have a doubt, why multiply the c with whole square with into 1 square, right? So there is an explanation for it. See, the both of these two pair of straight lines, as it is mentioned in the question, we have to find the origin to the point of joining to the intersection of this curve and the line, which means that both the pair of straight lines passes through the origin. What is the formula? What is the general form of a straight line passing through the origin? It is ax plus 2hxy plus c plus by uh, c, no, c equals to 0. You see, here must look at this. Ax square plus 2hxy plus by square is equals to 0, which means there are no constants or any single digit terms. Look at this. when we multiply it with g into g x, this will be an x square second degree, and g x into x, y my second degree, x into y second degree, and there will be a first degree term, which is when we multiply with g of x with k and g of x with 1. Still it's only a first degree term, it only passes through the origin, there is no c. If you add a c to it, that means the straight line which will not be going to through the origin. Here, to make the origin flow through this, go through the, to make the pair of straight line go through the origin, we multiply it with whole square. If it is not a square, c into there you can see there is a constant in here. When you multiply it with c with this one, you will get an answer, which is you will get a constant, which is not gonna be in the format of ax square plus 2hxy plus by square is equals to 0. Okay, let's see how it's gonna look like. There must be some mistake. It is supposed to be a straight line. Hy plus g into lx plus k plus 1. Oh, just a second. Yeah, there we are, guys. Seems that there is a mistake in this equation that we wrote for the homogeneous. Look at here, observe closely. The equation of a pair of straight line which passes through the origin have a format of ax square plus 2hxy plus by square. But when you multiply this gx with k or gx with 1, you will get a you will be having a gx kgx value, which means it will have a g value on the equation. So we have to change it into a format where there will be a 1 on the left hand side but no other silly variables like this k or any constants left on the other side. So to do the thing, all the constants must be went to our left hand side and we have to divide it with this. Okay, let's see. Lx plus my plus k is equals to 0, the equation. Therefore we can write it as lx plus y, no, let's make it k is equals to minus k. Okay, let's divide both sides with minus k. We will get lx this by minus k plus my over minus k equals to 1. Look here, there are no fuzzy constants here. When we multiply it, we only get second degree terms. There aren't any first degree terms when we multiply. But when we multiply this equation with lx plus my plus k plus 1, there are first degree terms. But look at here, because the equation is 1, the intersection point is fixed. If you want to take a closer look at here, whenever even if the line, look at the green line, wherever the green line goes, the intersection point is the same for these curves. Look, observe closely. So let's change the format into what we lx by minus k minus k plus y over minus k. Let's copy this thing. Control C. Now look at here. We arrived at this equation. Okay, lx by k. Look, this is the pair of straight line which passes through the origin. Because there aren't any fuzzy first degree or constants remained here, Every each and every term is a second degree. Look at here, ax square second degree, hxy second degree, by square second degree, g into lx, which is a second degree, x into x square will be x, g into gx into my will be a second degree term. There are no first degree terms. In the previous problem that we did, there are first degree terms. That is the reason we got the wrong answer. See, look at this question. Okay, finally, let's adjust the values according to the question. What is the value of the straight line? 3, -1 and 1, right? 3, -1, 1. Hmm. Look at the straight line. 3, -1, 1. Clear, right? Here, just look at the answer. We got two straight lines which are like this. Okay, but the question in the question they asked is what is the angle between these two straight lines. Here we have to find the angle between the two straight lines as it is mentioned in the formula. What is the formula for finding the angle between the two straight lines? The formula is cos theta is equals to mod a plus b by under root of a minus b whole square plus 2h whole square, right? But there's a catch over there. We cannot write it as it is the formula, because we have to simplify the equation. This gx into lx over minus k and plus my over minus k, we have to simplify this equation. So first write the cost. Let's find the theta. I'm taking theta as t is equals to cos inverse, open, mod, bracket open. Let's see what is the a. In the formula, in the cos theta formula, a referred to as x square coefficients. Here see what are the x square coefficients, a plus and gl. Let's see here, gl multiplied by lm, so gl over minus k. Observe clearly, gl over minus k. Clear? Gl over minus k, no, plus, and there is another c here. Let's expand this. That's small mistake. Cos inverse. Now open the bracket. A coefficient, x square coefficient. We have to write x square coefficients. A power, sorry, a plus c. Another x square coefficient, g into l x square. So plus gl by minus k. C. Then other plus c. You can see, right? C into x, cl into cl square x over k square. C L square over k square. And then next we have to find the b term. What is the b term? Y coefficients, y square coefficients. So open the bracket, b plus gm by minus k, m over minus k plus cm square over k square. Clear, right? Well then we have to find a root. So divide it by taking a root under root of a minus b. Just open a bracket. I'm gonna take a term minus b term bracket close, plus, and again it's an whole square. See, small mistakes can go. Then plus 2h whole square. So what is the value of 2h? It is the coefficient of x and y. So we have to take, like, calculate the x and y coefficients. H plus gm over minus k. Gm over minus k plus fl over minus k. L over minus k plus 2. Here you can see, when you expand this whole square term, there will be like 2 lmxy. So I'll write it as 2c over k square, which is minus k into minus k, it will be k square. No, sir. See? Okay, there we go. Here, look at this. We got the angle between the two straight lines. See, similar to here, the theta says 21 degrees, and the equation I got it for, like, instead removing the cos theta, the value of a plus b by root a minus b whole square plus h plus 2h whole square is 0.93, and cos inverse of 0.9321 is 21 degrees Celsius. Look at here, 21 degrees, the angle between. Okay, cool, right? The computation here seems a little bit complex, but try doing it on paper. It will get a lot clearer than just it looking at it. Okay, now let's look at another question. Here, let's see the second question. 7x. See, the question is the same. Observe it. They show that the line joining the origin to the point of intersection of the curve, some x7 x square blah blah blah, with the line 3x minus y equals to 2 are mutually perpendicular. See, let's substitute the values. A value b7, here, look at here, 3x minus y is equals to 2, which means when we move the 2 to left hand side, it will be minus 2. So I'm taking it minus 2. Okay, look at the graph here. Let me zoom and take. Okay, look at the graph here. This is the curve and this is the line, and we have to show that the angle between the curves is 90 degrees. Let's see. Yeah, look at here, theta is equals to 90. Fascinating, right? The cos inverse value is 0. Therefore, cos 0, like, in what value of 0 they will get cos 9, cos 90 is equals to 0. Look at here. So good, right? Fascinating, isn't it? Well, let's look at another question, which is a little bit difficult. Okay, see the 16th question. Find the value of k if the line joining the origin with the point of intersection of the curve 2x square minus 2xy plus 3 blah blah blah, and the line here. See, the line, there is a constant here instead of a fixed value like the other equations. There is a constant, are mutually perpendicular. Okay, we have to find the value of k when the angle, where the angle between the two pair of straight lines is 90 degrees. Okay, let's substitute the values here. 2, a value be 2, L y means 2, and k, if you get the side, let's assume I'm replacing the k with v minus v, which, because the k value here, right, that the k, when the k moves to this side, the answer will be minus, and I'm taking v instead of k, and I'm adding a slider to v. Okay, just look at this function. Okay, let's see how we're gonna tackle this problem. Okay, we have to find when the equation value is 90 degrees. See here. Okay, just move. By adjusting the v value, we are adjusting the k value, which means the line will move above and below. Okay, we have to find at what values the angles will be 90 degrees. Look at here how it is changing. Okay, I'm coming 78, 84, 90. At minus 1 the value is 90, which means the value of k is minus of minus 1, which is equals to 1. Okay, 1. And let's see, do we get another 90 degrees? Okay, see, even at 1 also it's become 90, minus of 1, minus 1, which means at 1 and negative 1 the angle between the two pair of straight lines is 90 degrees. We solved it. Look how beautiful this graphs and things look. See, however you may look, these three, the curve, the pair of straight line, and the line intersecting these two are concurrent. This is the magic of math.